is that?
Well, this is string art, right? You recognize string art. So the question is, I mean, you could have a string going from this one to this one, move up to the next hole, draw a string to it, and the envelope is a curve. What curve is it?
Bezier.
Well,
It's
a quadratic, it's a parabola, yeah.
parabola.
Actually a Bezier curve. If I take the end points and the corner point, those are the control points of this Bezier curve. How can I prove that? Well, it's iterated linear interpolation is the DiCastro algorithm, which is how you compute the Bezier curve. And so this is a Bezier curve, and it comes from string art. The interesting thing, though, is that every polynomial has a multi-affine function in higher dimensions. This is a quadratic polynomial.
Okay.
Because it's degree 2, that means in 2 dimensions it has a multi-affine function. What do I mean by multi-affine? That means in 2 dimensions you have a function which is composed of straight lines. You'll notice that every line in here is straight, but the surface is a saddle. It's a quadratic function. This function, this called the blossom of the polynomial, I like blossom because it kind of blossoms, it unfolds, will tell you an awful lot about the polynomial you wouldn't know otherwise. You can derive all kinds of algorithms and everything. The polynomial itself, this parabola, is the diagonal of the surface. So if I cut straight along that diagonal, I get
That shape.
And it doesn't matter how wide I open this or close it, it's always the same curve when I open that up and close it. I can't go into all the details, but this blossom, like I said, will tell you an awful lot about the polynomial that you wouldn't see by just looking at the polynomial. Every polynomial has a surface associated with it called the blossom. This is the blossom of a quadratic polynomial.